Hi, welcome to Data Science Byte-Sized Learning. In this video, I will discuss naive Bayes algorithm. In my previous videos, I have explained logistic regression, decision tree, random forest and KNN algorithms as part of classification machine learning techniques. In this video, I will explain naive Bayes classification technique. Naive Bayes algorithm is simple and intuitive, yet performs surprisingly well in many cases. For example, spam filter in email app is built on naive Bayes. The name naive is used because it assumes the features that go into the model is independent of each other. That is, changing the value of one feature does not directly influence or change the value of any other features used in the algorithm. It calculates the likelihood of all the classes given a set of features and finds outcome based on highest probability. Naive Bayes works well with high dimensional data such as text classification, email spam detection, etc. Firstly, let's understand conditional probability, which is the basis of Bayes theorem, and in turn understand the concept behind naive Bayes algorithm. In this example, assume that out of 100 students in a school, 40 students like nachos, 30 like chips, 20 like both, and rest of the students like neither. If a student is chosen at random who has bought nachos, what is the probability that he has also bought chips? To solve this problem of conditional probability, consider event A is students buying nachos and event B is students buying chips. Then probability of event A represented by P of A is 0.4. Probability of event B represented by P of B is 0.3, and probability of students buying both the items is represented by P of A intersection B is 0.2. Now, the probability of a student buying chips given that he had already bought nachos is represented by P of B given A is calculated as P of A intersection B divided by P of A, which results in 0.5. This is an example of conditional probability. Bayes' theorem shows the relationship between a conditional probability and its reverse form, the relationship between P of A given B and P of B given A. Let me explain naive Bayes algorithm with an example. Suppose that you want to build a classifier which says the given text is about sports or not. Consider the data set of text and its tag as a classifier. Now, which tag does the sentence "it was a close game" belong to? Since naive Bayes is a probabilistic classifier, we want to calculate the probability that the sentence "it was a close game" belongs to sports or non-sports tag. Then, we take the largest probability. Written mathematically, what we want is the probability that the tag of a sentence is sports given the sentence is "it was a close game." Naive Bayes will count each word occurrence in the training data set against all the data we have. For example, it will identify the word game is included in the text which are in the training data set. It will count two occurrences of the word game in the training data set. One in the text "a clean but unforgettable game" and two in the text "a great game." Hence, "it was a close game" will also be classified under sports tag. This way, the tag value will be assigned with the class having highest probability. This is just a simple example for understanding purpose. In reality, it is a very powerful algorithm capable of handling more complex data. Now that you have understood how naive Bayes theorem works, you have to tabulate confusion matrix to calculate accuracy and other metrics. Watch my earlier videos to understand how to tabulate a confusion matrix. Hope you enjoyed this video. Thank you, and we'll see you in another bite-sized learning video on data science.